introduce Matthew here to talk about maintaining the Agda standard library.
Great, thank you very much. Yes, as Richard says, I'm going to talk about the Agda standard library. Guillaume has agreed to be co-author on this talk, but please don't blame him for anything I say. He's helped, we've maintained it together, but the views are my own, not his. Agda is a dependently typed language that's a theorem prover. It's been used to formally verify all the standard sort of stuff, but people also write programs in it, like compilers and even a GUI, which is slightly an interesting choice of language, but I guess it's a proof of concept. The Agda standard library, therefore, needs to support all of these applications and use cases, and it's pretty big. It's north of 100,000 lines of code now, and a load of files, and it takes 4.4 gigabytes of RAM to type check the entire thing. My apologies to the reviewers of my abstract. I got this figure of how much memory it took slightly wrong, but I think the point stands. There's tons I could talk about today, but I'm going to focus on dependencies and problems we have with dependencies in the library. This is a dependency graph for data.rational. It's for rational numbers. It's pretty hideous, and this is with all our work trying to minimize it. Hopefully everyone's seen this meme about the heaviest objects in the universe, and at the right we have node modules. I'm not saying that data.rational is up there with node modules, but it's getting pretty heavy. Long way, yeah, pretty far along. So what are the reasons why users may dislike large dependency footprints? They may be philosophically opposed. They don't want their proof of correctness for their programming language to depend on Cantor's diagonalization arguments, for example. They may be mathematically opposed. They may have competing axioms in different modules. Some modules may use a k-axiom, and some people may want to work with univalence. Another slightly less obvious one is that it's a time required to type check. I mean, the whole library takes about 8-9 minutes to type check on my laptop. This is on boot up of a module, first type checking of a module. It's a bit irritating if your module takes 3 minutes to load a large portion of the standard library. And likewise, memory. I used to develop up until 2 years ago on a laptop with 4 gigabytes of RAM. I had a web browser open at the same time. If I imported the wrong module in the standard library, hit compile, my computer would start thrashing. And I'd have to reboot everything and retype check from start. So there's lots of pressure to have small files, small dependencies, which you can pick and mix from in the standard library. So again, I'm just going to talk about one small way in which we try and do this today, which is we try and separate out the definitions and computation of the types from the proofs that go along with that computation definitions. So for example, we have a set of base for every data type. We have a base module where we give the definitions. For instance, the definition of natural numbers, definition of addition. And then we have the property modules that go along with side of it. And where we have, for example, the proof of commutativity. And this is particularly useful for people who want to only verify part of their programs. They're writing a real-life program. They want to write code that runs, but they don't want to verify it. So they only need to import the base modules, and then the bits where they actually verify it, they can import the heavier weight dependencies on the property modules. So this is a diagram, and basically the guiding principle is that all the base modules should depend on each other. All the property modules will depend on each other, but the property modules can only depend on the base modules. So if you're importing base, you never get some of the larger property modules. And the property modules are large. They outweigh, they're about 20 times the size of the base modules in general, as a rule of thumb. So what are the problems with this setup? Well, let's consider the sorting function in Haskell. You have some sort of ordered data type, and you go from this to this. Well, the classic problem, of course, is that these algorithms only really produce meaningful output if the order is total. And in this type doesn't enforce it. The whole selling point of dependent types, right, is that we can change this in Agda to allow the function to take in a precondition that it is a total order and a proof that it is a total order. And this ensures that no one's going to use it in an order for which the function doesn't make sense. The problem is that to use this function, you have to open the property files, right? You can define it, that's fine, in a base module. But to actually use it, you're going to have to open properties, get a proof that the order that you're using is a total order, and supply it to the function. So what this means is that if you want to use sort in a base module, you've now got to bring in a dependency from the property modules, which violates the separation that we were trying to get. So the consequences of this seems to be that we can't enforce dependently typed preconditions in our functions if we want this separation. And this is kind of weird, right? Because this is one of the selling points of dependently typed theory, is that you can enforce these preconditions. So that's a bit irritating. I mean, I should clarify that it's perfectly fine to have dependently typed definitions and dependently typed, use dependent types in base modules. It's just these preconditions that violate the dependency graph that we're trying to achieve. And the other main point is that we now have to duplicate all these structures in the library. So for instance, because some algorithms work over monoids, for example, you'd have to have both a raw monoid without the laws, and then you'd have to have a separate definition of a monoid with the laws. So what's the second disadvantage? Well, it's actually a loss of ability to enforce abstraction. And I hope everyone agrees that abstraction barriers in software are important. Particularly in interactive theorem provers, where implementation details actually really matter. If in most non-dependently typed programming languages, if you change the implementation, as long as you're extensionally equal, you're golden. In interactive theorem provers, you're actually going to break everyone's proofs. So in Agda, we enforce barriers using the abstract keyword. Anything in an abstract block, you can't, outside of the abstract block, you can't look inside the definition. So you can't actually see these fields. This is the definition of rational numbers in Agda. And we are just about to change this in the standard library. So yes, we would really have liked to have previously erected an abstraction barrier here, but we didn't. And the problem is, right, now that we have all the proofs about the rational numbers, but the basic set of proofs about the rational numbers need to peer inside what the definition of the rational number is. But yet these proofs now live in a separate file, so they can't look inside the abstract block. So again, it appears if we want to have this dependency structure, we can't have abstraction. So how can we work around this? Well, we could have a new module. Let's call it data.rational.abstract. And we could import the base and property modules, and we could just redeclare all the definitions underneath the abstract block. And if they imported this module, they wouldn't be able to look inside of it. Well, what are the problems with this? It doesn't scale well. It's really difficult to maintain, because you have to duplicate everything, all the definitions from your other modules. And yeah, if you change one, you have to change it in 2 places. It also relies on convention. It doesn't stop the user of the library from importing data.rational.base. You'd like them to import the abstract one, but there's no guarantees. And we're back to square one, really, because it doesn't minimize dependencies. These abstract modules rely on both base and properties. So yeah, not great. Well, we could perhaps extend Agda to make the abstract block work over module re-exports, public module re-exports, so that this would work, and we wouldn't have to redefine everything. We could just open the module publicly. So this solves the first 2 problems, but it doesn't solve the second 2 problems. So what would a true solution in my mind look like? Well, it would require some sort of inter-module level access control. So at the moment, abstract blocks work over, you can define abstractions within modules. It would be great if we could really define abstraction barriers over multiple modules and enforce that in the library. And we would want support for both private and abstract keywords, private and abstract definitions. I should add, yeah, OK. And we could go, it occurred to me about a few days ago when I was giving this practice talk to someone else, that actually there's another solution, which is we can have much finer grained type checking of definitions, but which might solve the entire problem. But yeah, we'll come to that in the questions. Conclusions, well, dependencies are a problem if you're trying to create a large modular library used by everyone. Solutions to this can cause a lot more problems than they solve. Can Agda learn lessons from other systems? I mean, Java 9 module system was attempt to do exactly this, encapsulate multiple files underneath an abstraction barrier. We could use more precise dependencies, tracking between modules, or we can have better access control. I should also say that a lot of the just as a plug, there was a fantastic talk by Jesper on abstraction and computation, a manifesto a couple of years back, which addresses a lot of tangentially related abstraction issues that can feed into this sort of problem of reinforcing the barriers. So at this point, it's traditional to ask for questions, but actually, questions are great. I would really prefer solutions from the audience.
Any questions or solutions? I see one posted online.
Okay.
Has anyone on the Agda team thought about adding SML-style where type to the module language?
So I am the wrong person to ask this because I am not on the core Agda development team. I am a user of Agda, so I have very little insight about what is.
I am on the development team, but I don't know this SML feature, so if someone can explain it to me, perhaps I can think about it, but I haven't thought about it yet.
Question, I guess, for everyone is that how do other systems, if anyone here is from Lean or Coq or Idris, how do these dependencies get managed in other systems?
Can I say something? For the where type, we come up with something similar to that, but that would be the next talk. And for the solution, it's focused. Let me stop here because we do have some ideas, but that's kind of maybe we should discuss.
Okay, sounds good.
I have a sort of, in Haskell, we do rely on convention. There's a lot of packages that will have something dot internal,
Yeah.
and then something, and there's nothing really stopping you from importing the dot internal,
Yeah.
but then you know that you lose things like abstraction if you do that. I guess what this makes me think about is that you want to separate out compilation unit from module.
Yes, yeah.
Which
Absolutely.
is something that also, I know in Haskell we really want to do that. Well, I really want to do that. I don't know about others, but I think that would sort of be something towards solving that. But you kind of mentioned that toward the end.
So a
Maybe
lot
we just
more
need to type check
fine-grained
questions.
type checking. If you didn't have to type check an entire module to bring in the definition, one definition. Yeah, absolutely.
Yeah.
But that's a scary thing to change.